Hello everyone, today is my first video for class 10th. In this video we'll be discussing about the mirror formula, how to understand and how to place the sign, the most important thing in the mirror formula. So see here, the mirror formula for the mirror is 1 by u plus 1 by v is equal to 1 by f. Now this formula we generally all of us remember, but the only problem we face is how to place the sign of u, v and f. So this we'll be discussing today. U stands for your object distance, V stands for image distance, and F is the focal length. And this I believe we all know that U is your object distance, V is image and F is the focal length. Now from which point are we measuring this distance? That is the pole. So for example, I am taking a concave mirror here. That's your pole, focus and center. We all know about these points. So whenever we are measuring the distance, let's say this is our object. Now since I have placed the object beyond center of curvature, so image has to be between F and C. So that's our image. So object distance U will be the position of object from the pole, whereas image distance is the distance of the image from the pole, focal length, distance of focus from the pole, which means that all the measurements in the mirror formula we are taking from point pole here. Right, now let's discuss about the sign convention, the most important thing in this mirror formula. So see, sign convention is quite easy, but once you have the clear understanding that why this sign has to be placed and how to change the sign and when to change the sign. So look here. This is your, in class 10 we are having only two spherical mirrors. One is your concave, other is your convex. So let's take both the mirrors together. Let this be your concave and this is your convex. Now concave and convex, if you have any difficulty in differentiating between these two. So concave is the one where reflection is taking place from the cave, from the inner part. So if the reflection is taking place from the inner part, then the polished surface should be the outer one. So outer surface is being polished and inner surface will act as a reflecting surface. That's a concave. Whereas for convex, it's the vice versa case. The polished surface is the inner one and the reflection is taking place from the outer curve. So this is your convex. Now let's jump to the sign convention. Now one thing you should know, and I believe you must be knowing, that object must be placed in the direction or on the side where the reflecting surface is there, because the reflection will take place only when the object is on the same side as of the reflecting surface. So here in case of concave, object must be placed here no matter at what point we want to place. We have to place this object on this side only. Whereas for the convex, since inner part is being polished, so the object must be placed on the outer surface side. So I mean, this thing you have to understand, that whenever we are placing the object either for concave or convex, we have to place them on the direct side of reflecting surface, not the side of the polished one. Right? Now if this part is clear, rest of the parts are very easy. Where object is being placed, that side is your negative side as per the sign convention. Right? Which means that your object position, that is U, this will always be negative. No matter we are talking about the concave mirror or convex mirror, this U has to be negative. Whereas we talk about the V now. Now we know V is your image position. Now just think of the ray diagram which you have done earlier, that image can be real or virtual, correct? So for concave mirror we have the possible cases, the image can be real as well as virtual. So when the image is real, since it is a mirror, so the reflected ray should be on the same side, right? So V must be negative for real images. Whereas it's positive for virtual images. Why so? Because these are the mirrors. They are reflecting the rays. So if we want to obtain a real image, the reflected rays must meet after reflection. And since reflection means bouncing back, so they bounce back in the same medium on the same side from where they were coming. That was the negative side. So if they actually meet on the negative side, we'll have a real image. That's the negative sign. Whereas if you are obtaining a virtual image, as in the case of your convex mirror as well as a special case of your concave too. See, so we have taken a light ray which diverges off. It appears to come from focus. Another ray diverge off, extend, and here we got the image. Right? So for convex mirror, the position of the image will always be on the other side because we are obtaining a virtual image. Right? So for V, we have negative for real image and positive for virtual image. Now let's jump to focal length now, that is F. Now for concave mirror, as you know that if you have drawn this curve, the center has to be on the left side. Then only you'll be able to draw this curve. So if center is on the left side, so will be the focus. It's just a trick to remember it. So the side on which we are having the center will be according to the curve. So this will be negative for concave. Let's move to convex now. In case of convex mirror, this is the curve. This is your sphere. So for this sphere, center has to be on the right side. Then only you'll be able to draw this curve. Right? Now since this side is your negative side where the object is being placed, other side has to be positive. So for convex mirror, your focal length will always be positive. Why? The focus lies inside or the focus lies on the other side of the mirror. Why so? Because for this curve, center has to be on the right side and so is the focus. So focal length is negative for concave mirror and it's positive for convex mirror. So this negative positive thing you have to remember. And I believe these all are quite easy to understand. Let's recall. Object position U always has to be negative because object will be placed the same side as sort of the reflecting surface. So it is always negative. V will be negative for the real image because real image will only be formed when we have actual intersection after reflection. And reflection will be on the same side. So V is negative for the real images whereas positive for the virtual image. When the light rays are being extended and they are meeting on the other side. Focal length negative for the concave mirror because this is your concave mirror. So to draw this curve, we have to place the center on the left side. That was the negative side. So is the focus. Similarly, for convex, focal length is positive since the center lies on the other side. Other side, that's the positive side. So this is positive. So just note them down to remember that U always negative, V negative for real, positive for virtual, and focal length negative for concave and positive for convex. Just pause the video and just write down these things. Okay, now moving on. Let's discuss about the height of the image sign and height of the object, and then we're discussing about the magnification. So see, to measure the height, we have to take a reference point, correct? So in case of your mirrors, either concave or convex, the height is always being measured from the principal axis. So this height is the distance of the object tip from the principal axis. Now since we are above the principal axis, so this will be taken as positive. Similarly, if there is a real image formation, and you know this already, the real images are always inverted. So this height is below the principal axis, so it will be taken as negative. So what we are getting here? We are getting here the height of the object is positive always, and height of the image is positive for virtual images, since the virtual images are always being formed erect for virtual image, and negative for real image. This is about the height of the object, height of the image. Height of the object always taken as positive because it's been taken always above the principal axis. Height of the image depends upon the real and the virtual nature. If it's a real image, that has to be negative because it will be an inverted one. It will be below the principal axis, whereas it has to be positive when we have a virtual image formation. Okay, this was about H, height of the object and image. Now moving next to the magnification. See. The formula for magnification in a mirror is M equal to minus V by U. This M gives us the idea how big or small the image is in comparison to the object. And the formula is minus V by U. Now please remember, this minus sign is in the formula itself. It is not for V, it is not for U, it's in the formula itself. So whenever you are calculating magnification, you have to take care of this sign. So if say we have a case for real image. Okay, so M R for real image, negative sign as it is. Now in the previous part we have discussed that V is negative for real image. It's on the same side. So this will be a negative sign. U is always negative. This negative will cancel out this negative. We have a negative sign for real image. This is again important fact which you have to remember, that magnification is negative for the real images, whereas it's positive for virtual images. How come? That you can see on your own here. This will be negative as it is again, and V for virtual image. Now this time V will be positive. This negative sign for the formula, U will be negative again. This negative cancel out this negative. This positive will be left, and we have a positive sign. So M is negative for the real image and positive for the virtual image. Now the last part, how on the basis of the value of M we can tell about the image. This is the last thing about the mirror formula. Afterwards you can do any type of question based on this formula. See, so if we have value of M as positive, that's a virtual image. If it's negative, that's a real image. If this value is greater than 1, then we'll have a magnified image. And if this value is less than 1, we have a diminished image. And if this value is equal to 1, we have same size image. Now if you say that how sir magnification we calculate from height of the image and object, if they are given to you, then the formula is quite easy then. That is M equivalent to height of image upon height of object, which is equivalent to minus V by U as we have seen earlier. So either way you can calculate the magnification either from the height of image and object or applying the formula V by U. But do remember that if you are applying the height of image and object, do consider the sign. Sign like if the image is real, then height will be negative. If the image is virtual, then height will be positive, and so on. So I believe this mirror formula is clear. In the next video, we'll be discussing about the lens formula.